right, my friends, today we are really digging in and taking all of the different concepts we've learned and practiced throughout this chapter to focus on comparing decimals. There are so many different real-world examples of where and when we might need to do this. Think about different running events. In running events, athletes are timed in fractions of a second, and then those times are compared to determine the results. Scientists record and compare information about different species of plants and animals, all using decimal values. And lastly, when we're shopping, we can compare money amounts to find a better value. So there's a lot of really important real-world experiences that we have that require us to be able to compare decimals. And today we're going to take a look at what that might look like in different situations. So let's jump into this problem. The city park covers 64/100ths a square mile. About 18/100ths of the park is covered by water, and about 2/10ths of the park is covered by paved walkways. Is more of the park covered by water or paved walkways? So we're going to go through a couple different strategies that we can use in order to find out which decimal is larger so that we can know if more of the park is covered by water or if more of the park is covered by walkways. So let's start by thinking about the numbers we're dealing with, right? We know that we have 18/100ths of the park that is covered by water. And then we have 2/10ths of the park that is covered by walkways. Let's think about using a model to help us with this comparison. Let's start by thinking about 18/100ths. I know that I'm going to be using a grid that's divided into 100 sections because my denominator is 100, right? I'm thinking 18/100ths. So if I do that, I know that one whole column is 10. So I'm going to shade one whole column. And then I need to shade 8 more in order to get to 18/100ths, which is just too short of another column. So I'm going to shade all of the ones in the next column except for the last 2. And now this model shows me 18/100ths. Then I'm going to use a model that's separated into tenths. Since this shows me this decimal tells me there's 2/10ths of the area that's covered by walkways. And so I know I need to shade 2 of my sections on my grid here. And if I shade 2 entire sections, I'm noticing now that 2/10ths is a little bit more shaded than 18/100ths, right? I have these 2 last squares in my row that aren't shaded in 18/100ths. So this model helps me find that 18/100ths is less than 2/10ths. But let's continue by looking at another strategy that we could use, which is a number line, right? If we have a number line here, and my number line starts at 0 and 0/10ths and moves all the way to 0 and 5/10ths, right? I'm going to find these 2 points on our number line. I'm going to find 2/10ths and 18/100ths. Well, it's easy for me to find 2/10ths right now because that's clearly labeled on my number line, right? Right here is 2/10ths. So that represents our walkways. 18/100ths is somewhere in between 1/10 and 2/10ths, but I know it's more than halfway in between these two numbers. So I'm going to go ahead and put 18/10ths right about here. This number line helps me see that 18/10ths is closer to 0 than 2/10ths. So I know that 2/10ths again is larger. So this is how our number line can help us answer the same question using a different strategy. Lastly, we can also just think about place value when we're comparing these numbers. So we can simply think we have 18/100ths and we have 20/100ths, right? Because we know that 2/10ths is also equivalent to 20/100ths. Then we compare which one is more, and we know that 20 is more than 18. And so we can easily see again that 20/100ths is greater than 18/100ths. So to answer our question, is more of the park covered by water or paved by walkways? Our answer would be more of the park is covered in walkways. And you might even put that inequality statement there to help prove your point.